Okay. We just start recording, so I am uncompressing the virtual machine of GNS3, the one that you can download from the cloud that I gave you. Okay, done. I'm going to start GNS3. And try to do the same lab that we were trying to do. Okay, so the problem was with the cloud. So I better check that the cloud is working perfectly before we continue. So the project will be Y-Shark01. Okay, so here I look for a cloud that is called NAT. Let me give it a name like NAT because we will have just one. I need a hub. It will be here. Okay, let me call it hub because we will just have one. And I need some PCs. So let me bring here one PC. We call it PC1 for now. And duplicate it. And let's see if we can make the NAT cloud work. Okay. So I'm going to start my PC. And connect to my PC to see. Okay, it have an IP address, that was that. My virtual machine did have a problem. So what I can do, I can duplicate this PC to have a third PC and create some server also, as we did previously. So I'm going to duplicate a PC, rename it server1, and duplicate. Oh, before I duplicate it, let's change the icon that is associated with the server. So I go here, change symbol. In the classical symbol, which are the one that we are using in this moment, I search for an icon of a server, and here it is. Let me duplicate it. So we have two servers. All of them are Debian machine, Debian virtual machines. So I'm going to connect the first server, the second server. Okay, we are done. So PC1 I've just boot. We have the icon here of PC1. We have the terminal. I'm going to change the name of PC1. So you already know that there is this file, etc hostname, that have one line. I'm going to change this line with PC1. With Control X, I'm going to exit. Yes, I want to change. Enter to say I want to keep this name. And to make it easy, I just reboot PC1. So I'm going to start while PC1 is booting. I'm going to start PC2. I'm going to start PC3. I'm going to start the server and do the same thing, no? Just put their name. So when we are in those devices, just by seeing the prompt, like here, we know what is the name of the device. So it's make easier to understand what I'm doing. So let's wait for PC2 to boot. Okay. I'm going to change the name. So the file is etc hostname, and put here PC2. Let me boot it to make it easier. Well, I can just exit and re-enter. Oh, I forgot to put the command hostname also, hostname PC2. Let me exit It's now called PC2 and I re-enter. So PC2 is okay. PC1 is okay also. Let me get the IP address of PC1. So with the command ifconfig, we can get the IP address. This is the IP address of PC1. So I'm going to put it on here with a text. So click here. This is the IP address of PC1. Maybe I can just put .173 because it's so difficult here because the screen resolution is very low. I'm going to put .173. Okay, this is the IP address of PC1, and the network is this network. It's 192.168.122.0/24. I need the IP address of PC2. Let me get it. And it's .26. So let me duplicate this. It's there. Here we are going to put, by DHCP, I got an IP address which is .26. Okay, let me get the IP address of server 1. This is server 1. I'm going to call it server 1, hostname, SVR1. I'm going to put this SVR1 in the file. Instead of editing it, I can do this, echo SVR1 in the file etc hostname. And this will be the same thing. Let me exit and re-enter. Okay. It is called SVR. Oh, I need the IP address of SVR1. The IP address is .114. So let me duplicate this one. And here we have .114. Okay, so I'm going to use Wireshark to capture the traffic. Wireshark, the capture of traffic, network administrator do that because it's a way to know what is going on in your network, and you can know many things about what is going on in your network. Let me see if I can get rid of this. There is a okay, could get rid. I don't like it. Okay, so this is a hub, which means that if PC1 sends something, it will be copied to PC2, to PC3, to server 2, to server 1, and to the NAT cloud also, which gives me access to the internet. So Wireshark have this possibility that you can put your cursor over a link, right-click, and start a capture. It will say, I'm going to start a capture in this Ethernet link. I'm going to say OK. And we will have Wireshark, which graphic GUI tools that capture traffic. So let me try to accommodate it here. We have 3 panels in Wireshark. The upper panel that you have here is called the list of packets, the packet list. Here we have the packet details, and here we have the packet bytes in the last panel. So in this moment, Wireshark is capturing traffic. So what I'm going to do to see the traffic that we are capturing, I'm going to ping, for example, from PC1 to PC2. And the ping are ICMP echo requests, ICMP echo reply packets. I will see them there. So let me go back to PC1, and I'm going to use the command ping -c for count. Let me do it 4 times. And the IP address of PC2 is 192.168.122 see if I can put .26. .26. So what will happen here is that PC1 will send an ICMP echo request to PC2, and PC2 will answer with an ICMP echo reply. And that will be done 4 times. So I'm going to capture 8 ICMP packets. It will be ICMP echo request, ICMP echo reply. So the request will go, oh, the IP address stay here. The request will go from 192.168.122.173 to 192.168.122.26. And the reply go from PC2 to PC1. So it will go from 192.168.122.26 to 192.168.122.173. So I still have my sniffer here, which is Wireshark running, and I'm going to ping. So we will see them, they will appear here. And it's very probable that at the beginning, we will have some ARP request, ARP reply. It's very probable if you know already what is this protocol. So let me do it. 1, 2, 3, 4. And look at in the capture, we have exactly the traffic that I just told you. So Wireshark is still capturing. I'm going to stop the capture because I want to study those packets. So when you want to stop the capture, you have this icon here. I'm going to stop it. And as you can see, Wireshark have stopped capturing the traffic. And now I can go through my panels and study the packet that we just received. So as you can see here, the first column is the number of the packet. So packet number 91 is the first ICMP echo request. So as you can see here, we have the time at which the packet was captured. So it was captured since the beginning of the capture. It was captured in second 172.36. Here we have the source IP address. So let me put GNS3 again. So of course, the source will be 192.168.122.173, and the destination will be 192.168.122.26. So look at it here. We have the source IP address 192.168.122.173, and the destination IP address 192.168.122.26. And in layer 3, we have ICMP. And this is an ICMP echo request. Then the following packet, which is this one, if you look, which is packet number 92, go from PC2, which is 192.168.122.26, to PC1, 192.168.122.173. And there is after another echo request that go from PC1 to PC2, an echo reply. An echo request, an echo reply, an echo request, an echo reply. Why? Because when I run the command, I say I want to send 4 ICMP echo requests. So let me show you the command again. It was ping -C4 Is there a way for me to? Okay, here is the command. Ping -C4 count, send it 4 to this destination IP address, which is the IP address of PC2. So it's why we capture 4. So here in the list, in the packet list, you select the packet that you are interested in. For example, I'm going to select the first echo request. And you can resize the packet list and the packet details. Here we have the packet details. So if you are a little familiar with networking, you know that we have layers in TCP/IP. So the layer 2, which is the data link layer, is here. The layer 3, which is the network layer, is here. And layer 4, which is the transport layer, is here. And there is a term that we define in networking, which is encapsulation, when data is inside other data. So look at layer 4 is inside layer 3, which is inside layer 2. So in layer 2, we define what we call MAC addresses. So I'm going to open here layer 2 to have details about the layer 2. And look at, we have the destination MAC address and the source MAC address. So since this packet go from PC1 to PC2, this will be the MAC address of PC2. So I can verify that the MAC address of PC2 is 0C BD 94570000. So I can go in PC2 and ask PC2 its MAC address. By the way, the command is already there. ifconfig will show me the IP address of PC2, but also here it will show me the MAC address of PC2. So we can compare this MAC address 0C BD 94570000. So this is the MAC address of PC2. This is the destination MAC address. Now, the source MAC address, of course, is going to be the MAC address of PC1. So if I go here and I ask PC1, show me your network configuration with ifconfig, let me do ifconfig ATH0. So we have just the information of this interface. We will have the IP address in this interface, and we will have also the MAC address in this interface. So look at the MAC address. It have to be the source MAC address. So 0C 10 1D 5A 0000. So as you can see, in layer 2 we do have the MAC addresses and they are correct. Now, if I go back to the packet details, I can open also the information of the IP header. And in the information of the IP header, I will find the source IP address and the destination IP address. Of course, they appear here like a summary. So the source IP address is 192.168.122.173, which is this one that we can see here, which is the IP address of PC1, and the destination IP address, which appear here, or here in the summary, is the IP address of PC2. So that is in layer 3. So what is interesting here, for example, that we have, you remember that in layer 1, we talk about a series of bits. The PDU in layer 1 is a series of bits. So this is what is going to travel into the medium, which is a copper cable. This is a list of a series of bits. No, this is the packet byte. So if I want to know, for example, here I have the source IP address, where the source IP address is in the packet byte, I just click on the field here, and it will automatically be shown here. Let me click again. As you see, it's C0. So C is 12. 12 times 16 is 192. Then we have A8. So A is 10. 10 times 16 is 160. Plus 8 is 168. Then we have 7A. 7 times 16 is 112. 112 plus A, which is 10, is 122. And AD will be A is 10. 10 times 60 is 160. 160 plus D is 13, will be 173. So this is where the IPv4 address, the source IPv4 address, is inside the packet. The next 4 bytes are going to be the destination IP address. So if I click here, it will show me in this panel, which is called the packet byte. It will show me in the packet byte where is 192.168.122.26, which is the IP address of the destination. The same thing, for example, if I want to see where are the MAC address, So here we have the destination MAC address. And the MAC address is 6 bytes long. It will be the first 6 bytes. So it will be 12 bytes, 6 bytes. So let me click on the destination MAC address. Let me click again, and you can see it did highlight the 0C BD 94570000 in the packet byte. No? And after that, we have the source MAC address, which is the following 6 bytes, which is 0C10 that I can see here. The problem is that if I try to put the mouse here, it will select other field. It's why I try to avoid to go to this panel, because it will show me other field. No? As you move, it's show you fields that are related. So for example, this is the source MAC address, this is the destination MAC address, this is an IP address, this is another IP address. Okay, so we can find the information like the bits that are going to travel into the wire. Okay, so this tool is very powerful. Let me show you things that we can do with this tool. We have, for example, a way to filter. But before I start to do filtering, here we have, as you can see, a place where we can type. It says apply a display filter. We have display filter and capture filter. So the display filter is you already have captured some traffic, and you want to specify which one of the packet that you want to keep in the packet list. In this moment, all of them are in the packet list. I captured a little more than 100 packets, 110 in total. They are all there. But I can, for example, specify I just want some of them. So since this capture is very limited, I'm going to close it. I'm not going to save it, quit without saving, and I'm going to do a new capture. So I go back here, I close the magnify glass that appear here, and I open a new capture from scratch. So a magnify glass come back, and let me make appear the window of Wireshark. Wireshark is capturing again, as you can see. So what I'm going to do is much more traffic. So for example, in server 1, I want to install a telnet server. So there is no telnet server in this moment in server 1. I can verify it because a telnet server have port 23 open. There is a tool where you can ask, show me all the ports that are open for TCP, and telnet work with TCP. So the tool is called netstat for net statistic. So -n is numeric. Show me all the information like numbers, not like names. T for TCP, A for all. So show me all the TCP connection that are open in this computer. So in this moment, as you can see, the table is empty, saying that there is not one TCP connection open. So since I need a telnet server, I need to go to the repository and bring a telnet server. There is one that is called telnet-d. So before I do it, as you know, we need to do apt-get update. What is the objective of doing apt-get update?
Drop in packages like in list, maybe have more recent stuff.
So yeah, I go to the internet, to the repository of Debian, and I bring a fresh list of packets. Because I have a list here locally in my hard disk, but this list might be obsolete, because last time that I did this operation, it was a long time ago. So the people that develop Debian, when they find a bug, they put new version of the software. So I just saying there, okay, update the list of packets that you have locally. So it will go to the repository and bring a new list. So let me hit enter. Of course, this generates traffic. So you can see Wireshark is capturing the traffic here in the background. And it brings a new list. So now what I'm going to do that I have a new list, I'm going to install what I need. So I'm going to say install telnet D, which is a telnet server. So in the list, it did find telnet D, and it's telling me, okay, if you want to install telnet D, you also have to install some dependency. Do you agree, yes or no? I'm going to say yes. So it's going to bring the dependency. So as you can see, we have 1, 2, 3, 4, 5. A total of 5 that we need to install. So 4 dependency plus what I need. 1, 2, 3, 4, 5, 6. Sorry, it's 6 because with telnet D, so 5 dependency plus telnet D, so it will bring 6. So look at the first one, the second one, the third one, the fourth, the fifth, and telnet D. So it's bring them and install them locally. So now I'm going to type the same command. netstat -numerical T for TCP all. And look what we have. The table is not empty anymore. And we have here, this entry is the one that I want you to see. This entry is the fact that I just use apt-get. It will disappear in a few seconds. Okay, it's still waiting for it to die, but it will disappear. But this one is going to stay. So this one say that locally, in any IPv4 address that I have, TCP port 23 is open and is accepting requests from any client, which means any IP address with any port. Okay, let me check. Look, now the second entry have disappeared, as you can see. We just have the fact that telnet is in this machine and telnet is working. So in this machine, we have only 2 users. We have the root user and we have Eric. Let's create some user in this machine. So to add user, I'm going to use the command add user. Let's create, for example, John, the user John. So the password, let me put John. Let's put John password. John, capital P, password. It's a little long to type. Okay, it's going to be John. Let's put John Carpenter. So room, I don't want to specify the room where John works. I don't want to specify his phone number where at the office, at home neither. Other information of him is not important. Is this correct? Yes. So we have a user that is called John. Let's create another user that is called Sally. So let's put the password Sally password. Sally password. She's going to be Sally Thompson, for example, or Johnson. Okay, Johnson. Sally Johnson. The number of the office, the phone number at work, the phone number at home, or other information. Is this correct? Yes. So we have 2 users now in the server, and we have a telnet server. So I'm going to check that the telnet server is working, which means that, let's say that PC1 is the computer of Sally, and Sally wants to make some change in the server. So she needs either to walk in the data center and go to the console of the server and make the change, or she might just use the tools like telnet. Telnet allows her to connect to the server, enter in the server, and make modifications. So she used a PC, which is PC1, and she don't want to walk in the data center. The data center many times is a place that is closed and very cold. so people don't like to go there, and it might be very far away. So she is in her office, and she wants to make some maintenance in the server. So what she can do, she can use a tool that is called Telnet. We have a Telnet client here, and in the other side there is a Telnet server. And she's going to put either the IP address of the server, or for example, since we have a DHCP server, I can put server 1. I can put that, for example, or the IP address of the server. Let's put the IP address of the server for now. So what is the IP address of the server? 192.168.122.114 at the end. So 198.162.122.114. Okay, so the capture list is going on in Wireshark. As soon as we type that, we will see telnet traffic. So let me do it. Let me see if we can accommodate that. Okay, let me do it. And look at the telnet traffic. It's captured here by Wireshark. And this is the server that is answering me and telling me, okay, you want to access the server, please give me your username. So she's Sally. So she puts Sally. Give me your password. I'm going to put Sally password as we define it when we create the user. And look at Sally is connecting to server 1, as you can see. So every command that I type here will not be in the PC of Sally, will be in the server because she remote connected to the server. For example, let's say that she is in a home directory and she wants to verify that with print working directory. It say, oh, you are in the directory /home/Sally. Let's say that she wants to create 5 files that are empty. We can use the command touch. Let's call them file 1 to 5.txt. Okay, I just type the command and look at them. They were created file 1, file 2, file 3, file 4, file 5. I can list them. They have size 0. They belong to the user Sally, to the group Sally. They were just created. This is the modification date, which is the creation date in this moment. And this is the name of the file. Okay, then that was what she needs to do. She's going to exit and come back to this PC. So I'm going to type exit, and as you can see, I am back to my PC. Okay, this is the user that is called Sally, and she is back to her PC. Okay, so let's create a little more traffic. For example, here, I am in PC2, and I'm going to ping the other PCs. So since I have a DNS server, I can do, for example, ping, and I can put the name PC1. So the DNS server is going to resolve PC1 into an IP address. Of course, the IP address of PC1 is 192.168.122.173. So the DNS server is going to say to PC1 that the IP address of PC2. Oh, I am in PC2. I'm doing ping PC1. The IP address of PC1 is 192.168.122.173. So let me do it. And let's do it 2 times. So look at, you see this IP address, PC1 got it. This is the IP address of PC1, sorry. PC2 got it through a service that is called DNS. So in the capture, we will have DNS traffic before the echo request and echo reply. So if you look here, look at, we have DNS traffic, and then we have the echo request, echo reply, echo request, echo reply. So this DNS, domain name system, is the conversion of, look at, there is a query first. Please, can you resolve PC1 into an IP address? So this is PC2 that is asking that to the DNS server. And the DNS server says, okay, the IP address associated to PC1 is 192.168.122.173. So it did work. Let's see if PC3, we have not put the name of PC3 here. So let me do it. Host name, PC3, and I'm going also to echo it in etc host name. Let me init PC6 again, so it have this its correct name and IP address. Oh, we need the IP address of PC3, so I need to wait PC3 to boot to get the IP address and report the IP address in GNS3. So we know it. So let me see. The IP address of PC3 is .239. So here, I'm going to copy that. And we are going to put .239 here. This is what the DHCP server gave it. Okay, so from PC2, for example, I can do ping PC3. And there will be a resolution also from this name to an IP address, which is 192.168.122.239. So let's do it. As you can see, the resolution was done. The ping was done. If I go to the capture, I will have this information. So as you can see, first, let me go. It is there. It is totally at the end. We have a resolution through DNS. So here we have the query. So who is asking is PC2. And is asking to the DNS server, can you resolve PC3 into an IP address? And the DNS server say, okay, the IP address associated with PC3 is 192.168.122.239. And then we have the echo requests that go from here it is. So we have the echo request that go from 26 to 239, which is PC2 to PC3. And the reply goes from 239 to 26, which is PC3 to PC2. Okay, as we can see here with the IP address. So from PC3 to PC2 is 239 to 26. Okay, so it is working fine. I am going also, for example, may I put some web traffic? Yeah, I can do that. So do I have curl? I don't have curl. So I'm going to install curl here. Curl is a web client, which is text oriented. So we don't need to have something like Chrome or Firefox, which is big, which require a lot of memory. I can just use curl. And curl will do the same thing, but of course, since it's not graphical oriented, it will just download the page and show me the page in HTML format. So I'm going to do apt get update at the level of PC1 because I want to install curl. Then apt get install curl. So it's telling me there is extra packet, that's fine. Download them, install all that so I can benefit of curl. And we are going, for example, to download the web page of the university with curl, the main page. So we can do curl http www.jsu.edu. And this is, let me do, the document have been moved. So it say that it's HTTPS. So it's move it to HTTPS. Look, so now we did bring the web page of JSU. Now let me see. Okay, curl performance execution. So I'm going to, as you can see, it say that it could not verify the authentication. So let's do that. This is the web page. It's big one. As you can see, it's where we have this picture all of JSU at the beginning. So now I have a lot of traffic in my capture. I'm going to stop it, and we are going to start studying this traffic. So it's still going on the capture. As you can see, we have 3,100 packets that have been captured in this moment. So let me stop the traffic. Okay, I can save it. Let me save it. Save. So it will create a pickup file. Pickup NG, which is pickup new generation. It was to be pickup in the past like that, but now it's storing it as pickup new generation. Okay, that's fine. I'm going to put it on the desktop, and I'm going to put it as capture. Okay, so we have a lot of traffic here. It's difficult to know what is what. So for example, I am interested in capturing a specific traffic. For example, all the traffic that was starting by PC1. So if I want to do that, I can put a filter here. So look at possible filter that we have. IP source. IP source is the way to specify a specific IP address. Equal, and I'm going to put the IP address of PC1, 192.168.122. Let's see the IP address of PC1. 173. When the filter is okay, you can see that the box where I enter the information is in green. So I'm going to hit enter. It will only select the packets that I just specified. So if you look in the list here, we don't have all the packets. It say, for example, in total we have 3,103 packets. And in this moment, in the display here, in the packet list, we have 422. So not all of them are here. So we can see, for example, here I'm totally in the upper part. The first packet is packet number 462. Then we have 595, 597, 598. So as you can see, some are missing. So I was saying that as source address, I want the IP address of PC1. As you can see here, in source address, we have the IP address of PC1, which is 192.168.122.173. So PC1 at one point communicate with the DHCP server. PC1 communicate with 114, which is server 1. Let's verify that. 114 is server 1, as you can see. PC1 communicates, all this is with server 1. We were doing the telnet station. It's communicate, for example, with 26. 26, I think, is PC2. We can verify. Yeah, 26 is PC2. So it did communicate with PC2 at one point. Then blah, 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 blah. But the source IP address is always the IP address of PC1. Now, if I want, so those are packets that PC1 sent. Now, if I want the packet that PC1 received, what do you think how can I change the filter? What change will you make here if you want the packet that PC1 received? So you will put ip.dest, DST. So look, when I'm here, let me show you again. You type IP. Let me do it from scratch. IP dot, it shows you all the possible options. So you can scroll down and look like the one that you are looking for. I'm looking for IP des. So they are alphabetically ordered, and here we have IP des. So IP destination is equal with double equal on the IP address of PC1 because I want the packet that PC1 receive. So 192.168.122. What is the IP address of PC1 again? 173 at the end. So 173. And I'm going to hit enter and look at. Now, in the destination IP address, I will have only, as you can see here, which is the destination IP address, I will have only the IP address of PC1. So of a total of 3,103 packets, as you can see in the display, in this moment, we have 1,718. So 1,718 of this packet were packets that were going toward PC1. And as you can see here, on the side, we can see, for example, this is the DHCP server that is sending something to PC1. This is the telnet server that is sending something to PC1, etc. So now I ask you, how can I want packets that were either sent by PC2 or received by PC2? What can I do? So PC2 is 192.168.122.26. So look at what I can do. I can do, for example, the IP source can be 192.168.122.26, or the IP destination, the ST, can be 192.168.122.26. So I can put or. When I hit enter, it will select of the 3,103 packet, the one that corresponds to that. So look, if you look at the first packet that was selected, which is packet 873, look at the source IP address. It's the one of PC2. If you look at this packet, which is the 874, look at the destination IP address. So I was saying either PC2 is the source or PC2 is the destination. So here PC2 is the source. Here PC2 is the destination. Here PC2 is the source. Here is the destination. Here is the source, destination, source, destination. Okay, it doesn't have to be like that. No, it can be source, source, source also. Let's try to, okay, there is no traffic where is the source, source, but it could be the source several times or the destination several times. But as you can see, we have it as the source or as the destination. Another way to do the OR is you can use the pipe. So instead of typing OR, you can use the pipe. It will be the same thing. The filter works the same way. So there is also an IP address. So another way to do that, you can type here IPADDR. And when you type IPADDR, you just say, I want the IP address in the packet to be this one. So you don't specify if it's the source or the destination. So it will bring both of them. So let me do it. And as you can see here, we have PC2 as the source, and here PC2 as the destination. So it brings all of them. And we have 22 in total, where PC2 have been either the source or the destination. So this is another way to do this. Now, let's say that I am interested in the DNS traffic. What do you know about DNS? DNS use what? TCP or UDP? DNS use a combination of both. Sometimes it uses UDP, sometimes it uses TCP. But most of the time, DNS use UDP. For small queries, DNS use UDP. So the queries that we have been doing here are small queries. In this case, DNS use UDP. So look what I can do. I can say UDP. This is a filter. Show me all the UDP traffic. So it will show me the DNS traffic, but for example, DHCP also use UDP. So it will show me at least the DNS traffic and the DHCP. Look at in this moment, we have DHCP traffic, DNS traffic, but we have ICMP traffic also. So this one is going to disappear. That was the previous filter, no? I have not hit enter up to now. We have 22 packets in the packet list. Let me apply this filter, UDP. Now look, we have 63 packets. And look, we have DNS traffic and DHCP traffic because both of them use UDP. You see DNS, DHCP, DNS, DHCP traffic. Okay. I'm just interested in the DNS traffic. So how can I do it? So I know that DNS use UDP and DNS use a port, which is port 53. So here you can type dot and port. Look at, you have port, or you have destination port, or you have source port. So there is a source port here also. I just want to say all the DNS traffic. So I'm going to say UDP port equals 53. And this will select the DNS traffic. Look, so now in the display, I have just 50 packets. And if I scroll down or up, all of them are DNS traffic, as you can see now. So DNS is a service that allows you to ask, for example, a name and resolve a name into an IP address. So look here. Here I'm resolving, for example, the name server1 into an IP address. So let me do a small capture. Should I do that now? No. Okay, so this is the DNS traffic. You can see, for example, if I want only the answers, look at, this is a query. This is a query. So it's a standard query, and this is a response to the query. So here I say, can you please resolve the name archive.debian.erg into an IPv4 address? When there is only an A in the query, I'm asking to resolve it. So look at the answer. The IPv4 address associated with this name are the ones that are in the list here. So let me scroll right here. So they are here. So I better maybe open here and I will see them. So there are three answers and they are here. So this is one of the IP address. Look, if you want to see this IP address, I can use a tool. Let me go, for example, even in my Windows machine. You see this IP address? Let me try it from my Windows machine. They are here. And here I am at my Windows machine. And I can use a tool that is called NSLOOKUP. The type of resolution that I want to do is A for archive.debian.org. Look at the IP address that it's resolved. So let's compare them with what we have here. They should be the same. So we have here 130.89, 148.13, which is the last one that we have here. 217, 196, 149.234, which is the one that we have in the middle here, and 193, 62, 202.28, which is the first one. You see, so I can interrogate my DNS server. For example, I can say, I want the IPv6 address. So the type of query, I want to resolve this name in IPv6 address. Look at the answer. There is two answers. So if you look in the traffic that I capture, there are also a query. Please, can you resolve this name archive.debian.org in IPv6 addresses? And look at the answer. The answer is there. And look at inside. There are two addresses. If you look here, number of answer 2, and the answer is here. This is traffic that you capture. When you get familiar to it, all this you will be able to do it without problem. So if you look at the first one here, is the first one here that the window machine capture answer, and the second one is the second one here. So you see, let me go back. So another way to get, for example, you want this time only the queries. Here we have query and answer at the same time. And as you can see, we have 50 in total. So if I want only the query, what can I do? The DNS query. So remember, a DNS server listens on port 53. So if it's a query will go to from a client to a server, which means that the UDP port, the destination port, should be 53. So look at what I can put here. Destination port, DST port, equals 53. And look, now I have 20. Of the 15, I have only 25, sorry, I have 25, which is the half of them, because a query have an answer, a query have an answer. So of course, if I have both, I have 50, I have 25, and look at, all of them are query. Let's see that all of them are query. Look at here, I try to resolve server 1 into IPv4 addresses, server 1 into IPv6 addresses, PC1 into IPv4 addresses, PC1 into IPv6 addresses. The PTR is a reverse resolution, but all of them are queries. They are not answers. So they will go from computer in my network to the DNS server. On the DNS server, I have the IP address 192.168.122.1. So they will go all IP address here can be, for example, this one is server 1, I think so. Let's check it again. The one that ends in 114. Do I have my Wireshark? Where do I have my GNS3? Oh, it is there. So the one that is ending 114 is server 1. What I was saying, you know? The one, for example, that ends with 26 is PC2. So PC2 interrogate the DNS server. The one that ends with 173 is PC1. PC1 interrogate the DNS server. The one, okay, there is no more. So if I want now the answer, those are the query. How can I get the answer? So the source port will be 53. If the packet go from the DNS server to the DNS client, which is PC1, PC2, PC3, server 1, server 2, the source port will be 53. So of course, all the IP address here will be always .1 when I hit enter. So I just hit enter, and we should have 25 answer. Those are answer. So we have 25 answer, and look at the source IP address is always the same one, which is the IP address of the DNS server. So if I scroll down, you see the source IP address does not change. Now the destination IP address, this is the IP address of PC1. This is the IP address of PC2. This is the IP address of server 1. Okay, look another way to get information of DNS. We have a filter that is called DNS. We can just type DNS. So if you type DNS, it will bring all the DNS query and answer, which are 15. As you can see, display 15. Okay, we have 26, 25 query, 25 answer. So we can type DNS. Now, if we want for example, the DHCP traffic. So DHCP use UDP. And the port of the client is 68, and the port of the server is 67. So look at what I can say. I can say it's a UDP traffic, and the port is equal to 68, which is a client, or it's UDP traffic, and the port is equal to PORT, sorry, 67, which is a DHCP server. So when I hit here, we will only have DHCP traffic. UDP port, UDP port, okay? So I misspelled UDP. As soon as I change it, it can become green. Look, I typed enter, and look at here, protocol DHCP, DHCP. If I scroll down, all is DHCP. So look, if you look in layer 4, look at the source port, 68, destination port, 67. These go from the client to the server. The server is also running in 192.168.122.1 because this is the cloud. The cloud is identified by this IP address. So this is something that goes from a DHCP client, so port 68, to a DHCP server, port 67. And let's see, for example, here. By seeing the IP address, this goes from the server to the client. So look at the source IP, the source port. The source port is 67, which corresponds to the server, and the destination port is 68. So you see, we have all the traffic of DHCP. So let's say now that I'm interested in the traffic of, for example, Telnet. We did a Telnet session. Telnet use UDP or use TCP? Telnet use TCP. So if I want the TCP traffic, I can just type TCP. There is a filter that is called TCP. It will bring me all the TCP traffic. So we did have HTTP traffic, which is TCP. We did have Telnet traffic, which is TCP. So they will appear there. So I will not only have Telnet traffic. Let me enter. Let's see, let's scroll down to see, look, we have Telnet traffic, which is TCP, and we have HTTP traffic, as you can see, because both are over TCP. And we have also TCP, which TCP is connection oriented, so it have a lot of traffic to manage the fact that it's connection oriented. But we have both. We have HTTP and we have Telnet traffic, as you can see. If I want just the HTTP traffic, there is a filter. So look at in this moment, of the 3,103 packets, 2,424 were selected as TCP traffic. If I want to say just the HTTP traffic, there is a filter that is called HTTP. So I can just type HTTP. And look at here in the field protocol, we have HTTP. I can scroll up, scroll down. All of them are HTTP. And now there is only 74 packets that are HTTP. And let's see what we have in this HTTP traffic. Do you remember that I connect to JSU? So we should see that. Did I connect to JSU before I? Yeah, I did connect to JSU before I was capturing. I was still capturing, no? Because all this is getting the list of repository. Oh, sorry. It have to be HTTPS. Oh, JSU. This is something that I did against JSU because it have the JSU inside. Let me see if I can. Oh, of course, it will be since I'm using TLS. I'm using HTTPS. The way that I can filter it, for example, is with port 443. So I can say TCP port equal 443. This is what I did with JSU. So this IP address 10.85.3.2 is the web server of JSU. So we can check it, no? So it's 10.85.3.2. So let me go to my Windows machine, for example, and I'm going to resolve www.jsu.edu. 10.85.3.2, as you can see, no? Which is when you are inside the JSU, this is the IP address of the server of JSU. So this is my initial connection to the server of JSU. So we have a sync ACK, which is typical, and then we have TLS. With TLS, it's difficult to see what is inside because we use cryptography. So we were not able to understand the data that is inside. Okay, I want to go back to telnet. So if I want to filter on telnet, I can type telnet. This is the telnet traffic. So this is my station with the telnet server. So remember, the telnet server have IP address 114, and I was in PC1, which has IP address 173. So this is one of the packets of the exchange through the telnet server. So let me open them. Let me open some of them. We continue, suppress. See if we can find something that is more interesting. Echo. Don't echo. This is the very beginning of exchange. Let me go here. Oh, look at this A. This A is because at one point I typed A. So maybe it was the A of Sally. Let's see before. We have a S. Look at, you see this S? It's go from the client, which is 173, to the server, which is 140. So PC1 tell the server, the person just hit S. And look at the answer of the server. Display S in the screen. I will start typing the logging of the user. Then look at, it's go from the client to the server. The person just type A. The server answer display A on the screen. Okay, the person, which is me, just tap L. The server answer display L on the screen. Look at here. The person just tap L. Display L on the screen. The person just tap Y. Display Y on the screen. The person just type enter. Look at the server answering. Display enter on the screen. Then display password. Ask the person for the password. So the server is saying, okay, I already have the username. So show on the screen of the user password. So the person have to type the password. Let's see what is coming. So the person just, you remember the password is Sally password. So I'm typing the password. The person just type S. It doesn't say display S. You remember when we type the password, it doesn't show it. The person just type A. The person just type L. The person just type L. The person just type Y. The person type capital P, A, S, S, W, O, R, D, and enter. So of course, look at the password. The password is there in clear text. I can, since I have a copy of the traffic, I can get the password. So the server, the telnet server say, okay, go to the next line on the screen of the client and show a welcome message. On a telnet, it show me Debian, Linux. Okay, so look at. And then it show me the prompt. So this is the server telling the client, show the prompt. The first thing that I type is pwd. So I type a P. The server answers, show the P. I type a W. The server say, show the W. I type a D. The server say, show the D. I type enter. And the server say, go to the next line. So I type PW, print working directory. And then we have what? Let's go from the client to the server. So we should have more data here. Oh, okay, look at. So the server say, go to the next line and show that the current directory is home Sally. Okay, then I type T, the server say show T, then I type O, the server say show O, then I type U, the server say show U, then I type touch. You remember I type touch to create the file. So C, the server say show C, I type H, the server say show H, space, F, I, L, E, curly brace, 1, dot, 5, curly brace, dot, and txt. So T 2 times, X 2 times, T 2 times. Then we have the enter, and the server just say show enter. Then I type and show the prompt. Then I type ls for list, LL, SS, enter, and it shows me the list of the file. So you see, I can get all the conversation, but Wireshark have a very nice tools. We can see that the conversation was in clear text, but Wireshark have something like that. You take any packet of this telnet session, you right click here, and you have a follow TCP stream. And look at, it shows you in a window what was done. So look at one point, the server asked me what was my logging. So I type S, what I type is in red. The server echo S, I type A, the server echo A, I type L, then I type L, then I type Y. So the server asks what is the server is in blue. The server type asks me the password. Look at, I type my password, Sally password. Then the server show me a message of welcome. Then I type print working directory. And the server show me my working directory. Then I type touch file 1.5.txt. Then I type ls, the server show me the list of file. Then I type ls-l, the server show me the file in long format, and I type exit, and I was done. But look at the problem. The problem is here. Look at the password. So why telnet should not be used? Because telnet was done a long time ago. If Telnet do use authentication, because you are required to type your username and your password. The problem is this username and this password go in clear text in the network, which means that if somebody captures the traffic, this person will be able to do what we are doing here. This person will be able to use Wireshark, follow the TCP stream, and get all the conversation that you did on Telnet and get your password. So it's why Telnet should not be used anymore. It was good a few years ago. So look, if you are using Wi-Fi and the access point is open, which means that we are not encrypting between the station, the wireless station, and the access point. Any people that is sniffing the traffic that go to the access point will get your traffic in clear text. So if you use Telnet, it will get your password because your password go in clear text. It's why you should not use Telnet. And we have new tools to replace Telnet. Can you tell me what we should use? SSH, correct. So we can go, for example, in the server and install a SSH server. So look at in server 1, in this moment, I have just a Telnet server. Port 23 is open. What is the port of SSH? 22, correct. And SSH use what? UDP or TCP? TCP, correct. So look what I'm going to do. apt get install open secure shell server. It will first go to the repository and bring all the file that we need and the dependency. So it will show me the list of dependency that it will bring. Let me do it. So it say that it's going to bring one dependency, which is anchor term, just one dependency. So it will download the secure shell server plus anchor term. So only two, and we'll install them. So this is the first one, this is the second one. Anchor term and open secure shell server were downloaded, and it just install it. And it generates keys. You remember we studied that. RSA, Ravish Shamir Adelman for the public and private key. So it generates keys for the server. It generates a RSA key. We didn't see this one, but we did see RSA key. So now if I look my open port, I should have 22 open. So I still have 23, which is Telnet, but I should have 22. So look at this one is Telnet. Now this one is secure shell for IPv4. And this one, you see the port, the local port that is open is 22. This one also is secure shell, but for IPv6. So it will support secure shell on both protocols, IPv4 and IPv6. And this one will die. This is because I just download something, it's closing this connection, the apt get. So if I do it again, it is not there. So as you can see, this is local port. Look at an option that is interesting, P, for process. Show me the process that is opening this port. So maybe I'm going to open it a little more so we can see it better. Look at, with 22, it says that the process is secure shell daemon. And this is the process ID. So listening on port 22 of any IPv6 address, the same process. And listening on port 23, there is a process that is called inetd, which serve, this is a meta process, which serve the Telnet server. So you can get a list of process. That will be a full list of process. And of course, this process will be there. The 2709 will be in the list. So let me get a list of processes. Look at all the processes that are running in the machine. So let's find the 27. Where it is, where it is. Do you see it? Here it is. 2709. You see it? Is the secure shell daemon that is running. The other one, let me do it the command again, was the inetd daemon, which is a meta daemon. It's the 2371. It should be in the list. So let me put, so we don't have to search a lot. Let me put less, and we are going to search for inetd, which is 2371. So inetd, here it is in the list. 2371 is the process ID. So what can I do? Now that I know that my machine is at risk, because people can telnet, and I don't want people to telnet. Look, in PC1, if John, let's do John this time, or let's go in PC2. PC2, this is the PC of John. If John wants to telnet to the server, it can do it. Telnet SVR1. Oh, I'm not using I know what is happening. SVR1. Okay, look. So I'm going to enter John and John password. John password. And I'm in the server. I don't want this to be possible. So I need to do something in the server. What can I do? I don't want this process. I can kill the process, no? The process ID is this one. So there were one of the question of homework 1 is give a list of process, kill one process with the process ID. So we can do kill -9 on the process ID, which is 2371. If I look now in the list, it is not there anymore. You see, it is not there. We have a connection here. Oh, this is the connection. Oh, this is the connection of that John did, but it is dying. It will disappear in a few seconds. Okay, so now if I go and John wants to connect again, it will not be able. You see, connection refused because I killed the process. So the problem is that killing the process doesn't mean that you disable the service. So let's say that, okay, I killed the process, the problem is over. And we reboot the machine one day. The server, we did some maintenance and we did the big maintenance, we have to reboot the server. The telnet daemon will go up again because we killed the process temporarily. So the telnet daemon will come again. So let me show you. I go as root tool. I look at the list of TCP port that I have open, and it is running the telnet daemon again. So unfortunately, it is there, as you can see. So of course, killing a process in this case is not the solution, because killing is just killing a process, but every time that you start the machine, the process will start again. So what do you need to do? I need to stop the service, or I need to disinstall. I will recommend disinstall it, because you can stop the service in this moment and say, when you start up the machine, don't let the service go up. But if it is installed, at one point, you might enable it again. So the best thing is apt-get purge is to remove something that you install. So I install telnet D. So look at, he's saying that he's going to remove telnet D. The following package will be removed. Okay, yes. So now there is no way for me to, of course, if I look at the list, it is not there anymore. And if I boot the machine, it will not appear anymore. Let me boot the machine because I remove the file. I remove the software of telnet D. So if I enter here and I do a netstat numerical alt TCP, telnet is not running. What is running is secure shell, but telnet is not running. So John tried to telnet and he cannot telnet. So he called the network administrator, and the network administrator said, oh, we are sorry, we are not using telnet anymore. You have to use secure shell. So he finally learned how to use secure shell. So John arrobas this machine. So the first time that I connect, the server will give me its certificate. So the secure shell client will say, okay, I got a certificate from the server. Do you accept it? I will say yes. What is your password? Let me enter John password. And I'm in the machine there. I am in the server. But this is encrypted. Even if somebody captured the traffic, I don't worry because this is encrypted. I can exit. If I connect again, since I already have the certificate, the second time that I connect, it doesn't ask me if I want the certificate because I already have the certificate in my local account as the user John. So I'm going to type John password and we are inside the server. Okay, let's stop here for today. I'm sorry I took a little more time, but we also lose some time at the beginning. Okay, so I see you. I hope this was instructive and help you with the homework that you have in this moment.